Now we now want to consider a third type of differential equations, which I've labeled exact differential equations. So starting off, if you consider the expression u, function of x and y, as being equal to 3xy plus 2x squared plus 5y plus 8, just some random equation which I've written down. If you differentiate implicitly, what you get is the total differential of uxy will be, doing this term by term, 3 bracket x dy plus y dx plus 4x dx plus 5 dy. And rearranging to collect the dx's together, the dy's together, we get this expression here. 3y plus 4x times dx equals 3x plus 5y times dy. The expression 2 is called the exact differential of the expression 1. Now, if you were given that as a differential equation, in other words, number 2, and it was equated to 0, to solve that differential equation, we need to find a function, uxy, whose total differential is the expression in 2. And of course that is 1, because that's how we've just worked through it. Now, so one important thing I need to point out first, and I've written down as a note here, that the exact differential of a function of x and y, which I call u equals and is equal to 0, is given by du equals partial du dx plus partial du dy dy. Now, I want you to familiarize yourself with this expression, because it is used a great deal in problems involving differentiating. And it's so important that I call it a weapons grade formula. Okay, so familiarize yourself with that, because you will need it again and again and again if you continue your studies of maths. Okay, we now proceed to solving an exact equation. So I've written down a differential equation here, which is m, a function of x and y, dx, plus n, another function of x and y, dy, equals 0. And I'm stating that it is exact if and only if the partial derivative of m with respect to y and the partial derivative of n with respect to x are equal. I'm saying I'm not going to prove this here, simply on the grounds that it's going to divert me from the main purpose of this particular little video. And the purpose of this little video is, how are we going to solve this equation, which is 90% of the interest as far as most people are concerned. Right, now I've written down 6 examples here, and I'm going to do the solutions to 1 and 3. I've written down the solutions in the brackets at the end of the questions there, so if you want to practice them, you'll be able to refer to them, and hopefully I haven't made any mistakes. Okay, so I'll give you a little bit of time to write these down before continuing. I'm still here. I'm still here. Right, I'm still here, and I'll continue now with this. If you haven't had time to write them down, you can rerun the video and have a look at them again later. So let's go to the first question. So written it down again, and we want to solve the differential equation 6x plus 4y dx plus 4x plus 5 dy equal 0. Now, first of all, we need to show that this is an exact equation. So the partial derivative of m with respect to y is simply 4. And likewise, the partial derivative of n with respect to x is also 4. So the equation is exact. And the solution uxy must have the total differential, which we've mentioned before, partial du dx plus partial du dy, so that partial du dx is equal to 6x plus 4y, and partial dy is equal to 4x plus 5. And so integrating, remember that in the first one, you regard it as a function of x only, because that's a partial derivative of u with respect to x. We'll get u equal to 3x squared plus 4xy plus f of y, where f of y is a function that is completely free of x, so that when you differentiated it with respect to x, you would get 0. And likewise, for the second part, you also get u equal to 4xy, that's integrating with respect to y. Repeat that again, u equals 4xy plus 5y plus g of x, where this time gx is completely free of y. So now we've got two expressions for u, and of course common sense says they must be identical. So writing this down from here, over here, u is identical to 3x squared plus 4xy plus f of y, which is also identical to 4xy plus 5y plus g of x. So this can only mean that g of x is 3x squared and f of y is 5y. Either way, u is equal to 3x squared plus 4xy plus 5y. And so the general solution of our differential equation is 3x squared plus 4xy plus 5y equals a constant c. Noting that when we integrate the right-hand side of the equation, we'd have to put down a constant there, because when you differentiate a constant, that is 0. Okay? So that deals with the first problem. Then I'm going to do number 3. And the method is practically the same. Hardly any difference at all. This time we want to find the general solution to the equation sine y plus e to the x cos y dx plus x cos y minus e to the x sine y plus 2 dy equals 0. Again, if we differentiate m with respect to y, we get cos y equals minus e to the x sine y. And when we differentiate n partially with respect to x, we get cos y minus e to the x sine y. So obviously then now these two expressions are equal and the equation is exact. Okay, so proceeding as before, if uxy is the solution, then partial du dx will be sine y plus e to the x cos y. That's the m part. And integrating with respect to x, you get x sine y plus e to the x cos y plus f of y. And similarly, du dy is, or partial du dy is x cos y minus e to the x sine y plus 2, which on integrating with respect to y, keeping x fixed, is u equals x sine y plus e to the x cos y plus 2y plus g of x, where, as before, f of y is free of x and g of x is free of y. So either we have, because these two expressions must be equal, because they're both equal to u, we either got f of y equals 2y and g of x equals 0. Either way, you will end up with u equal to x sine y plus e to the x cos y plus 2y, and so the general solution is x sine y plus e to the x cos y plus 2y equals a constant c. And that brings us to the end of this rather lengthy video. Thank you for your patience and thank you for listening.